Write the equation of harmonic oscillatory motion with an amplitude of 5 cm if 150 oscillations are performed during 1 minute and the initial oscillation phase is 45 degrees, and draw the diagram of this motion. Okay, so let us assume that the equation is of this form, which it is omega t plus phi. So we can substitute the given facts, that A, which is the amplitude, is 5 cm, so this becomes a phi, and rest of the things are sine omega t plus phi. Okay, so what else is given? 150 oscillations are made in 1 minute. 1 minute is 60 seconds. So if I divide by 150, how many seconds does it take for one oscillation? Therefore, one oscillation will take 60 by 150 seconds, right? Which is what? 2 by 5, which is 0.4 seconds. So time taken for one oscillation is nothing but the time period, right? The time period is 0.4 seconds. Now, in the previous video, I told that time period is 2 pi by omega, right? But time period, as we know, we just found it out, is 0.4. So from here we can solve for omega, which comes out to be 2 pi over 0.4, which is what? 4 by 10, 5 pi. Omega is 5 pi. So let's substitute that here. So this becomes 5 times the sine of 5 pi, right? Omega is 5 pi, t plus phi. And now I might have forgotten to tell you that this phi here is called the initial phase angle. It depends on the initial which portion of time you have chosen as t equals 0. Okay, so yeah, so they have given the initial phase, oscillation phase is 45 degrees, right? So that should be equal to the 5 sine 5 pi t plus 45 degrees in radians is pi by 4. That's it, we are done. This is actually there's x, that is x. This is the equation of harmonic motion. So yeah, and they also asked us to draw a diagram of this motion. Okay, so you might have studied drawing the graphs of sine and cosine. So I'll just draw the axes here. Okay, so these are my axes. This is the y-axis. That is my x-axis. Okay, so this oh sorry, not y and x, but x and t, right? X and t, that is what we have to draw. So the this is a sine graph, so it's definitely going to look something like this. Let me draw a better one. Right, it's going to look something like that, but in this case the amplitude is phi, right? Not 1, which is the general case. So this line here is 1, this coordinate is 1, so that is the, oops, sorry, not 1, oh, that is 5, sorry, and this down part will be -5 as expected, because the minimum value of sine is -1, so the minimum x will be -5. Okay, and at t equals 0, this is 5 over square root of 2, right? So this is somewhere, oh, I mean, I should have drawn it later actually. this is not actually the graph that we want, but it is somewhat shifted, right? Because there is a pi by 4 there. So I'll just draw these lines that okay. So at t equals 0, it is sine of pi by 4, which is 1 over square root of 2. So x becomes 5 by square root of 2, which is just a bit less than 5. So he's going to start something like that, and it's going to be elongated. Okay, so it's going to look something like that. It's going to look something like that. Okay, and it is elongated because we have a 5 pi here, because the time at which x will be 0, which implies that sine becomes 0, is when the inside part becomes either 0 or pi, right? So if I put 5 pi t plus pi by 4 equal to pi, then I get that t is let's see, this becomes 3 pi by 4, so that is 3 over 20. So at 3 over 20 seconds, this becomes 0. Okay, so that time right there is where should I write it? I'll just mark it with an arrow. That is 3 over 20 seconds. Okay, so yeah, that's it, we are done. So I hope you like it. So we have used the general equation of an SHM, and we used the given facts. We used that 150 oscillations were completed in 1 minute. We used that to find the time period through which we found omega, and they had already given the phi, which is the phase angle, initial phase angle. We had omega, we also had amplitude. So I'll see you in the next video.